want to welcome everyone tonight. My name is Allison Arnold. I'm the Consumer Horticulture Agent here in Buncombe County for the Cooperative Extension Service. Myself and Steve Duckett, our County Extension Director, want to welcome everyone to our program today. I'll be your host, and we'll be making time for questions throughout the program. I want to welcome you to Understanding Climate Change in the North Carolina Mountains. This is session 2 of 3 sessions. It's a 3-part series. Tonight, our topic is climate change in the North Carolina mountains. Our speaker today is Rebecca Ward. She's the Assistant State Climatologist. And today, Rebecca will discuss how climate change works in our mountains and how it will impact our lives moving forward. I'm going to hand it over to you, Rebecca. Thank you for speaking with us tonight.
Thank you, Allison, and I'm excited to be here virtually speaking with you all. I just wanted to begin tonight's presentation with introducing myself for a little bit, since you probably don't know me. So I'm Rebecca Ward. I am a North Carolina native. I grew up in Eastern North Carolina along the coast in Carteret County, and then I came to NC State in 2007 to study meteorology. And then I kind of never left. So after I got my bachelor's degree in meteorology, I went on for my master's degree. And partway through that degree, I started working at the state climate office as a climatologist. And I really realized that my passion is for connecting climate to people, to decisions. I really like growing things and eating food that comes from North Carolina. So working anything with agriculture and climate is kind of my real passion. Where I work at the state climate office, we are a UNC, the UNC university system in North Carolina. We are a public service center with that system, and we are housed at NC State University, but we serve the whole state of North Carolina. And we have 3 core areas where we focus our attention in our work. We're a staff of about 10 people, and we do have some undergraduate and graduate students who work with us. So the first area is research. So we do a lot of applied climate research, looking at anything from how can we understand precipitation patterns to help Department of Transportation design better culverts, to looking at how do temperatures in the sand influence sea turtle gender. So we do kind of a lot, but all of it is very applied in nature. We do extension and education. So kind of this evening, I give a lot of climate talks to public groups, community groups, professional groups, K-12, about anything and everything related to climate or climate change in North Carolina. I also do, especially my job, I do a lot of listening and talking from government or public, listening to what are their climate questions and concerns, and use that to really inform the work we do, and especially the research we do. And then the last thing is we monitor the weather. So we actually maintain our own network of weather towers across the state. We have 43 stations. One is actually located in Buncombe County, not too far from us. And we measure a whole host of parameters every single minute of every single day. And all of these are publicly available for free on our website, which I have kind of throughout the presentation today. So that's just a little bit about the State Climate Office and me. Now on to the subject of today's presentation. So I'm going to be talking tonight about climate change in the North Carolina mountains. And I wanted to just begin and sort of listen to you on how, if you were to describe what is the climate, if you live in the mountains or you've traveled to the mountains, how would you describe the climate? And so if you're willing to participate, type it into the chat and try to do this in 3 words or less if you can. And I'll kind of monitor that. So I see somebody wrote microclimate zones. Yeah, for sure. Better than Ohio. I've never been to Ohio, so I can't speak for that, but I'll take your word for it. Moderate, changeable, temperate rainforest. I see a lot of temperate, 4 seasons, variable, erratic. Let's see, cooler than Raleigh. Yes, you never know what's going to happen next. Hotter, humid. Yes, I love these. These are exactly what I was hoping people would say, and keep those coming into this is just my attempt. I would say very variable. So these three tables I have here, I pulled from the National Centers for Environmental Information. This is part of the National Oceanic and Atmospheric Administration, or NOAA, and this center is actually located in Asheville, and they are this repository of climate data from all over the globe, the United States and North Carolina. So they really crunch a lot of numbers. And they recently released a new set of 30-year climate normals. So getting a sense of what does our climate look like right now for the past 30 years. And so I just pulled for 3 locations in the mountains. I pulled Asheville because that's pretty well known. I pulled Jefferson because I'm actually going to Jefferson this weekend and I've never been. So I said, oh, this will be a good chance to take a look and see what their climate is like. And then I pulled Lake Toxaway just because I knew that they were pretty wet in Lake Toxaway. So if we look at these 3 tables here, and I've actually got it on my other screen, so I'm going to turn my head so I can point this cursor. If we look at these columns here, so on the left is our maximum temperature. So if we kind of compare these values, we can see, they're a little different. Annually, Asheville is the warmest of these 3 locations at 67.8 degrees average annual temperature over the whole. And if we break it down looking at seasons, we can see that the maximum temperature in winter in Asheville is about 49.9. If we come down to Jefferson, it's about 45.6. If we come down to Lake Toxaway, it's about 48.1. So we have a little bit of different temperatures depending on where we are, our maximum temperatures. And we can see a similar thing with our minimum temperatures, maybe a little bit more pronounced. So our minimum temperatures, for example, in the winter in Asheville are about 30.7 degrees. We come down to Jefferson, they're about 23.5. So that's a lot colder than in Asheville. And then Lake Toxaway, a little bit closer to Asheville at 29.2. So our temperatures are definitely different. And I'll talk a little more. I think you all have already picked up on why they're different across the state when we have these really big microclimates in the mountains. What I really want to look at is this precipitation column. So this is the second from so Asheville's annual precipitation is about 40.61 inches. So it's actually a pretty dry spot in the state. It's in a shadow of the mountains. So we don't, compared to other parts of the state, and especially the mountains, we really don't get much precipitation there. In Jefferson, we get a little bit more. We get about 10 inches more, 50.95 inches per year. And then we come down to Lake Toxaway, and it actually gets more than Asheville and Jefferson combined. So they get about 96.34 inches per year. So it's pretty wet there. And so this is just to say that depending on where you are in the mountains, it really can change what type of climate you experience. And I saw a comment in the chat that the minimum temperature for Asheville seems too high. And I will say this is averaged over a 30-year period that these were determined. So as you'll see in my presentation tonight, we are seeing warming temperatures. And so what we're experiencing over the past 10 years may even be a little bit different than over the past 30. So I wanted to just talk very briefly about, what are the kind of static things that drive our climate in the mountains, and then by extension, our weather that we experience. And so mostly it's our location. So the first thing on this slide I have is latitude. So a lot of the comments that came in mentioned temperate or having seasons, and that comes from our latitude. We are far enough north of the equator that we do experience all 4 seasons. That latitude also means we get prevailing westerly. So sort of the climate cell that we're in across the globe. Our winds come from the west, which means that we can kind of look left on a weather map, right, and see where our weather is coming from. It's coming to us from the Great Plains, and before that's coming from the West Coast. The second piece is our proximity to water. So the Atlantic Ocean and the Gulf of Mexico supply really the whole Southeast, but also the mountains of North Carolina with lots of moisture. That's why we have such a nice humid climate. And you might think, gosh, the Atlantic Ocean and Gulf of Mexico are really far away from me, but on the scale that our weather happens on, they're actually quite close, and they really do pump a lot of that moisture. The next thing is the terrain. So this is the really big piece when it comes to the climate that you might experience in any location in the mountains, depending on where you are. So if you say you're on the windward side of a mountain or a range, then that wind, when that weather comes to you, that air is going to rise up over, it's going to cool down, it's going to precipitate. So you tend to have higher precipitation amounts, you tend to be a little bit cooler, versus if you're on the other side of the mountain, on the leeward side, where your air is now coming down over the mountain. As it comes down, it warms up and it dries out. So you tend to get less precipitation and be a little bit warmer. And then also just how high up you are. That'll influence, if you warmer at lower elevations, cooler at higher elevations generally. Some places you might get above the cloud deck, so you might be cooler, but maybe your precipitation is less because those clouds are actually just fog at your altitude or your elevation. And then the last thing are our climate patterns. Those really influence our weather on anything from like a weekly scale to a multi-decadal scale, so a couple of decades. And the two big ones that I listed here are the El Nino Southern Oscillation, which influences our winter weather in North Carolina and the Southeast. So when we are in an El Nino pattern, we typically see cooler winter temperatures and more precipitation over the course of the whole winter. When we're in a La Nina, we typically see warmer winters and drier weather. El Nino Southern Oscillation also influences hurricane activity. So when we are in La Nina conditions, we tend to see more active hurricane seasons versus El Ninos, which tend to be a little bit less active. The other pattern is the Bermuda high pressure, also called the Bermuda Azores. Every ocean across the globe has a big high pressure system sitting over it, and it kind of wiggles and wobbles day to day. So we can't really forecast it past about a week or so, but it sometimes when it elongates, it can extend over us in the Southeast. Really warm weather, dry weather, and that we don't get precipitation, and that's usually when we get heat waves and drought in the summertime. It's often associated with that. And I saw a comment in the chat: are we in an El Nino or a La Nina right now? And I confess that what we're in just flew out of my mind. I think we're in neutral conditions right now, and that we're expected to continue to be in neutral, which really just means no real guidance on what the rest of our winter might look like. So those are kind of the static things. On any given year, we might be a little bit warmer or cooler or drier or wetter or stormier than the previous year. And so we have some of that variability, but by and large, over long periods of time, our climate's pretty because of these factors. But then we throw in the human emissions of greenhouse gases, and we have a changing climate. And so that's what I'm going to talk about next. So before I jump into kind of my goals for this, which are to just leave you with not a lot of numbers and graphs, but just kind of a general sense of here's what we have seen, and here's what we are projected to. I wanted to just first give a quick note on some of the information sources. I will send these slides so that you have these, so don't feel that you have to write down every single link or number that you see. I want you to just not worry about that, because you'll have these at your disposal, but just to, I guess, listen and see the slides. So the first source of information is the National Centers for Environmental Information, that big repository for climate information that I mentioned, that's in Asheville. And so those are two links there to their website. The second is the 4th National Climate Assessment. This is a congressionally mandated report that comes out targeted every 5 years. So the most recent report was actually 2 parts. The first part was released in 2017, and then the second part was released in 2018. There's a really fantastic chapter on the southeastern United States. That's kind of as fine scale as it gets in terms of, it doesn't get as fine scale as the North Carolina mountains, but it does have some really great information in there. The next one is NASA's Global Climate Change page. If you're ever curious just to see globally where we are in terms of carbon dioxide or global temperature, they have it right up front and center on their website. And so that's kind of a nice resource. And then the last one is the North Carolina Climate Science Report. And I put an asterisk beside this because most of what I'm going to be showing tonight comes from this. So this was part of Governor Cooper's Executive Order 80. This was an independently prepared report by scientists in the state of North Carolina. And it really is a very high quality, rigorous report that covers the science of the changes that we are seeing and projected to see in the state of North Carolina. It's pretty technical, I will say. There is a really good executive summary that if you haven't read it and you'd like to, I would strongly encourage that. And then if you are looking for some reading to really dig into it, I do encourage you to read the report itself, or at least the chapter on the North Carolina mountains. And then the second note I wanted to make is about models and projections. So the things I'm going to be showing tonight when we go into the future, just to say that we, in an ideal situation, right, we would be able to have a second Earth that we could run some experiments on and see what actually is going to happen. But we don't have that. And so what we do instead is we create, models that reproduce the Earth, the Earth's physical processes, the chemical processes, how, life interacts with all of these. We train the model, and then we test it using historical data. So we say, can we replicate the climate? Can we replicate the warming and the changes that we have? And then once we feel really confident about that, then we run it under different future scenarios. And it's different scenarios, and so we have different future projections, because it's really hard to figure out what people are going to do. And by people, I mean across the entire globe. Climate change is caused by greenhouse gas emissions. And so we have two scenarios that are considered in the North Carolina Climate Science Report. The first is a high emission scenario. So this is kind of a business as usual. We continue emitting greenhouse gases into the future. We don't really stop. And then the second is a lower emission scenario, which says we kind of continue throughout the middle of this century, and then we really start to ramp. And I saw a question, if I could put that URL to the report in the chat. So I'll just type that out right now. I'm sorry, I capitalized that H, but that should still work for you. Yes. So then the last thing I want to say before I finally jump into the content of my talk is that I recognize that this is it's kind of scary. And so this is actually a picture of my cat. He likes to put his head in the corner sometimes. And when I think about climate change, or even after I give a climate change talk, I kind of feel like doing the same thing every now and then. So I do recognize that this is heavy, it's scary, it impacts us all. And so I don't want to leave you tonight feeling really down. There are reasons to be positive, and I'll try to end on some of those reasons. And hopefully, next week's talk by Kathy will really cover some of those actions that we can take. And so that should hopefully give us a little bit more positivity. All right, so finally onto the content. So climate change in the mountains. So this graph comes from the National Centers for Environmental Information. It's a Haywood graph, and if you look in the lower right, that's how you spell Haywood. So what this graph shows is it takes, for every single month, it looks at by year. So if it takes for this year, it looks at what is our average temperature for January, and then puts a point on the graph. And then it says, what's our average temperature for January through February, and then puts that point on the graph. All the way through, now we're at January through June, which is our last complete month. What's that average temperature, and puts that point in the graph. So it does this for every single year, for every single average for the year to date, and creates a line. So each one of those gray lines that you see is a year in our historical record. So this goes back to 1895. And then the 5 warmest years in that whole record are colored. So they're colored in these kind of warm colors. And then the 5 coolest are also colored. We have the average in this black line, and then 2021, I've drawn an arrow to, is that green line. So sorry, I should have said this. I pulled this graph for Asheville. So you can go to that URL, and you can do different selections if you'd like to see the whole United States. If you'd like to see North Carolina, you can also do counties or different regions of the state. So I just picked Asheville because I thought that would be a pretty good location to look at. So what we're seeing with this is for this year so far, we're actually kind of close to the average, to that long-term average, at least through the end of June. But if you look at those numbers on the right side there, so we see 2019, that was the warmest year on record for Asheville. And actually that's true for North Carolina as a whole as well. Then we have 2016, 2017, and 2012, and 2015. And if you were to extend those numbers down, you would see some other pretty recent years show up as well. And this is something that we're seeing. We are seeing warming temperatures. Another way to kind of visualize this comes from a colleague at the North Carolina Institute for Climate Studies, which is also located in Asheville. That's an NC State center. So this takes that long-term average and just plots things by color to say, if it's darker blue, that means it's much colder than that long-term average. If it's darker red, that means it's much warmer than that long-term average. So the darker the red it is, the warmer it is. The darker the blue it is, the cooler it is. So if we look at this, we can see that historical record going back to 1895 and see that, we've had some periods where we were warmer or cooler, but we get to the end of the record on the right and we see a lot of dark red. So we're seeing warming temperatures, and we're really seeing it pronounced in our more recent temperature record. So that's kind of the sort of big first key message is that our temperatures are warming. They're warming globally, they're warming nationally in North Carolina and in the North Carolina mountains. And that warming is accelerating. We're getting warmer, and we're getting warmer more quickly. But that warming isn't happening the same at all hours of the day or all times of the year. It's really concentrated. Oh, sorry, I should have said this first. We're warming, and we are projected to warm. So this is a graph that came from the North Carolina Climate Science Report. It's from the third chapter, which goes into the mountains. And it's showing for those two scenarios that I mentioned, that higher emission scenario and that lower emission scenario. So this higher emissions is this reddish color, and the lower emissions is this greenish color. So they're showing what all those the model projections are for kind of that training period. That's sort of this gray area. And then we break it out into those two emission scenarios to show what are the range of future possibilities we could see. And then this black line is just kind of a reference line to say what was that average temperature that we saw from 1970 to 2013 to kind of give a reference to say, are we above that, and by how much? So a couple of things from this is, right, so we have seen warming, and we are projected to continue to see that warming. Over the next couple of decades, it really doesn't matter what we do in terms of emissions globally. We're really locked into a certain level of warming. But once we get to the end of the century, it really starts to diverge how much warmer we're going to get. So under the lower scenario, we're looking at 2 to 6 degrees Fahrenheit of warming. Under that higher scenario, we're looking at 5 to 10 degrees Fahrenheit of warming. So pretty substantial difference. And again, it after about 2040 is when we're expecting that to really diverge based on what we do with our emissions, starting today. So sorry, now is my point on our warming isn't happening equally across all parts of our day or year. So really most of it is concentrated in the nighttime temperatures. So our nights are warming more quickly than our days. And I don't have a graph for this slide, I just have kind of bullet point notes. So one of the things that the Climate Science Report looked at were warm nights in the North Carolina mountains. So these are defined as nights that are 70 degrees Fahrenheit or warmer. And in that historical record, averaged across the mountains, there's about one warm night per year. So yes, there's some variability. So some nights or some locations might see more, but that's what that historical average was. But we're starting to see an increase in the number of warm nights. So just for example, over the 2010 to 2014 period, the average was about 3 nights per year that we got to 70 or warmer. And we're projected to see this continue. We're projected to see more in the future. So by the end of the century, under that lower emission scenario, looking at about a week to 3 more weeks per year with nights that don't get below 70 degrees. Under that higher emission scenario, we're looking at close to 1 to 2 months per year that don't get below 70 degrees. So the next thing that the report looked at as well, and that is, I think, especially maybe on people's minds considering what just happened out west and is kind of still happening out west, are hot days. So these in the report were defined as days that reached 90 degrees or higher. So pretty warm, or I guess hot. So climatologically, about 12 days per year in the North Carolina mountains. And in the historical record, there's really not a trend in these, a statistically significant trend that we can say with confidence. This is not just due to random variability. But we do know that that temperatures are getting warmer. And so it stands to reason that if our whole sort of temperature distribution is shifting to warmer, then having warmer, more hot days in the future is very realistic and likely. So this graph is showing from same sort of time period, looking at from 2020 is kind of right here. Oh, sorry, I'm looking at the wrong screen. 2020 is right towards the end of the century. And so we can see under that lower emission scenario, once we get to the end of the century, we're looking at 9 to 44 more days per year getting above this temperature. Under that higher scenario, we're looking at 31 to 91. So pretty substantial difference. Yeah. So something else we're seeing are fewer cold days and fewer cold nights. So for example, days where our minimum temperature gets below 32 degrees Fahrenheit, that's pretty common, especially in the wintertime for a lot of places in the mountains. We're looking at decreases of about a week to a month under that lower emission scenario by the end of the century, but under the higher emission scenario, it's basically looking at days where the minimum temperature gets below 32 degrees Fahrenheit being rare or non-existent in parts of the mountains. So pretty substantial change in what I think really coming from Eastern North Carolina and now living in Central North Carolina, I see the mountains as like the cool place where you actually get snow. And so that's probably not going to be something that's going to be in our future for the mountains. We will continue, though, to see outbreaks, at least over the next couple of decades, in cold weather outbreaks. There's a lot of research looking at the polar vortex and how stratospheric warming events can basically cause the jet stream to really dip down over lower latitudes, like down to Texas in February, and cause these really substantial cold air outbreaks. And so it's likely that we'll continue to see that. We have seen that in our past, and we would have those outbreaks even without climate change, but it does kind of seem to be ramping that up a little bit. So those are our temperatures. Now on to precipitation, starting also looking at this Haywood graph. So instead of looking at the average precipitation for the year to date, this is looking at the sum, so the total precipitation that's falling year to date. So again, every gray line is a different year. The 5 wettest years are outlined in these green colors. The 5 driest years are in the kind of yellows and browns. The long-term average is in the black line, and then this year is the blue line. And this is for Asheville. So looking at Asheville, a little bit above that long-term average. If we look at those wettest years, we can see 2018, which was a very wet year across the state. That was our record. And then 2013, another recent year, 1973, 2020, 2009. So kind of a mixture. And then on the driest too, we can see in the mountains, there's some recent years. So in our precipitation long-term, we don't actually see a trend in getting wetter or drier. There's no statistically significant trend in that. In terms of those projected changes, the models for the future, there's kind of a range. Some suggest we might get a little bit drier, but most suggest that we're probably going to see at least a slight increase in our total annual precipitation. So it's likely that we'll probably see some of that increase. But what's really, I think the more important thing that we're seeing is that the way that our precipitation is really starting to change. So what we're really starting to see is more intense precipitation. And this is a consequence of a warming atmosphere. So when the air warms, its ability to hold more water increases. And so my nice, simple thinking exercise is that I have pretty dry skin. And so in the winter time, the air is colder and it really can't hold as much moisture. And so me, living in that air, right, I have to put on a lot more lotion. My skin feels a lot more dry versus now in the summer, the air is warmer, it can hold a lot more moisture, and we have that supply of moisture where we live. So I definitely don't have to put on as much lotion. And so just how much does that increase amount to? So it's about, for every degree Fahrenheit rise in temperature, we see about a 4% increase in water vapor. And this matters because how much vapor is in the air really controls how intensely precipitation falls. And so as we hold more water vapor, as that air gets warmer, we're starting to see more intense precipitation events. This map is a national map, but I still think it kind of gets the point across, is that, I mentioned that our annual precipitation isn't really changing here in North Carolina or in the North Carolina mountains, but the proportion of that annual precipitation that is falling as an intense precipitation event is really changing. So what this is showing, this map is comparing two different 50-year periods. The most recent, like through 2016, that the 50-year period that ended that, compared to the one before. What was the change in how much of our total annual precipitation came from the top 1% of? And so the sort of bottom line from this is, we're seeing a pretty substantial increase in how much precipitation is coming as more intense events. And that's something that we're projected to continue to see into the future as well. Hurricanes, for the same reason that we see more intense precipitation, hurricanes are getting wetter. Other climate change impacts associated with hurricanes are that the strongest storms are likely to become stronger. There's not really, it's kind of mixed evidence on whether or not we'll see more or less storms. And there's really not any guidance on where hurricanes might go. And then I just, the impacts from having an intense precipitation event, whether it's caused by a hurricane or not, because we can certainly have them without hurricanes, it can be felt across the entire state, and especially in Asheville. So I just pulled this picture from last October. Oh, there was a question, sorry, I missed it, on does increased water vapor in the air impact air temperature? It can. So let me think how I'll say this. It's easier to warm or cool air that is dry. So this is kind of why in the desert you can get a lot hotter and you can get a lot cooler at night too. It's because there's not all this moisture. And so that's also one of the reasons why we're seeing our nighttime temperatures warm, is because we are more humid, because we have all this extra water vapor in the air. It's a little bit harder to cool down at night because we have just more water. The specific heat capacity of water is higher than just air. So yeah, so it does have an impact on our air temperature. And then somebody also asked, yeah, none of us will be alive at the end of the century. Me neither. Do I have any statistics about 10 to 20 years from now? I guess I didn't. I probably should have done that. I didn't really pull out those numbers in my presentation to say, what will it be in 10 years now? But I'll try to, at least when I show a graph, or I can come back to graphs, try to pull out those numbers so we can see. Basically, it's going to be, a little bit warmer than it is now, right? So then we have interactions, right? So our weather's not just temperature and precipitation. So we have those, they interact in ways to, for example, give us droughts. So, right, we don't really have a lot of, our confidence on whether our total annual precipitation is going to increase or decrease is a little bit less. We do think it's probably going to increase at least a little bit. But because of the way our precipitation patterns are changing, especially in the warmer months, with having these more intense precipitation events, is that between those events is probably going to be drier. So we have, if you think about over the course of a year, if if you're filling up a bucket, right? Historically, you can think you maybe took like a nice watering can to it and sort of sprinkled some water in every now and then. Under climate change, what we're starting to see and projected to see more of is just kind of dumping water in every now and then doing nothing for a while, and then doing another big drop of water into the bucket. And so for those times between rain events, we could see, we will have warmer temperatures, so increased evaporation. So we could see, short-term drought conditions develop more quickly. And then all else being equal, just because we will be warmer in the future, when we do have a drought, it's likely to be more severe. And so I think, like, we've experienced droughts in all parts of the state, especially the mountains. This picture came from the Chestnut Knob fire in 2016 during that drought. We've experienced droughts. We can expect to see more in the future. And so it's just, instead of the sort of, I guess, milder droughts, you might just see some of the more extreme. Wildfires, they're part of our climate. We have them in North Carolina and the Southeast. We do a lot of management through prescribed fires to really prevent outbreaks of wildfires. So in the future, because we're going to see those warming temperatures, because we're going to see longer periods between rains, the days that are going to be suitable to do those prescribed burns is probably going to decrease. And then, so that could be conducive to more fires, and then to more intense fires when we do have them. And then there's just, sort of not even the climate change side, but just the fact that we are a state that has a lot of people moving here, right? A lot of people building new houses. And, I won't make any, I love it here, so I want to live here. But as people move into forested areas, that puts, a house, puts property, puts people next to a place that maybe needs to burn to be a healthy ecosystem. So how do we manage that in the future? And then this is pretty much really, especially for the mountains, is just the rain snow transition line. So North Carolina, we're kind of in a cool latitude in that the sort of freezing line in the winter kind of wobbles over the state. And so while the mountains, if we have a winter weather event, I guess from my perspective, right, being a lower elevation person, seems to oftentimes get all snow, or at least all winter precipitation, freezing up. But because that freezing line wobbles over the state in the winter, we can have a lot of events that are a mixture, right? That's why we have sleet plus snow plus freezing rain and rain. As we move into the future, that line is going to shift northward. So previously we might have had all snow. Now we might have a combination of snow and sleet, or previously we might have had that wintry mix. Now we might just have all rain. So my key takeaways, take home points, are that we are getting warmer in the mountains and across the state. The nighttime temperatures are where we're seeing the most pronounced warming, but we do see warming in our daytime temperatures. In the future, we are projecting to see more hot days and more warm. Precipitation amounts aren't necessarily changing, or they might only change a little bit, but it is becoming more intense, including with hurricanes, which impact all parts of the state. And then future droughts are likely to have more severe impacts. And these all have implications for things like our growing season length, health impacts to people, plants, and animals. And so, we all, to some extent, we are already feeling the impacts of climate change in North Carolina, and we're going to continue to see them in the future. Who is impacted the most and how you're impacted is really going to depend. So I pulled these two graphics. So the first is, there's been a lot of recent really fantastic work looking at basically taking like US Census data and comparing it to places with what the temperature is, or what types of land cover, do they have parks or trees? And they're finding that places that have more Black or Hispanic residents tend to be a lot warmer. And so when we're talking about a heat wave, that has really big impacts for morbidity and mortality. The bottom image I pulled from, it's actually from West Virginia, but I was trying to pull something that kind of showed, who is impacted is also who is able to do something to protect, right, their house. So, can we own a house, right, where we can go in and actually make changes? Like in this case, this person is putting down insulation in there. Do we have a house that has air conditioning? Do I live in a floodplain? All of these things really impact our vulnerability in general to any sort of weather event. But climate change just kind of turns those dials, right? We see more heat impacts because of climate change. And so if you were already vulnerable, it just kind of increases that vulnerability. So then the solutions and the what can we do? So next week's talk's going to go much more into actions, but I did want to just, try to leave with a couple of things. So one thing that's really exciting is across the country, a lot of states and cities have been doing work to develop their own sustainability plans to address climate change. And there's kind of two things to think about in terms of actions, right? So there is adapting to changes. There is, saying, I know where my parents live in Eastern North Carolina. They're probably going to flood more because they are close enough that sea level rise is having an impact. So what can they do to just deal with that, right? Create more barriers so that their house doesn't get flooded. So that's adapting. And then there is mitigation, right? So this is actually trying to, pull carbon out of the atmosphere or stopping emissions, things to really deal with the bigger issue itself at the sort of root cause. So Asheville actually has a climate resilience plan. I put the URL there. And there's also that screenshot on the left is actually a climate resilient Asheville guide. I liked it because it kind of goes through the different types of, I guess, hazards that are faced and what climate change is doing to them, and what are some simple things that you could do, or at least just be thinking about doing. So I highly recommend just giving that a quick peruse. Two other sources are Project Drawdown and the Yale Climate Communications Group. both have just kind of nice quick lists of various types of actions that somebody could do. And then just to tease, next week, the topic of the talk is local climate change. How can citizens make impact? I will probably be joining just to listen in, so definitely attend if you can. My last slide is just, and again, I will send these out promptly after I finish, so you'll have them, are just some places if you want to stay updated, if you want to kind of see, what's new research, how does this, current year fit into the historical and future climate perspective. A couple of places. So my office, my fellow assistant state climatologist, Corey Davis, works on the North Carolina climate blog, does a lot of really great, everything from a summary of the past month, what types of weather did we experience and how does this fit with that bigger perspective, to some kind of more longer lens piece. North Carolina Institute for Climate Studies, they do a lot of really fascinating, great research. And I should have mentioned this earlier, that group led the North Carolina Climate Science Report. So they really are a group of top-notch research. The National Centers for Environmental Information, they have a great news site as well. And then finally, NC State University, they actually have a tag for climate change related news. And I really like that because they have, it's not just, I guess, climate specific climate news. So it'll be a lot of research news about, hops for beer. How is that impacted by climate change? Or I think something came across today or yesterday about how do we, develop new soybean varieties that can feed the globe, still have lots of nutrients under climate change. And so with that, I will just say thank you. And there's my contact information. If you think of a question in the future, please feel free to email me. You're on social media. Yeah. So I saw somebody, Diane said, my cat is hiding. What's the good news? So the good news is that we can't, so this is a human created problem. Granted, none of the, 50 of us on the Zoom site, none of us created this by ourselves, right? But we live in a system, and this is, been going on for 100 years, and humans create it, which means that we can actually solve it. And there are becoming more and more, it seems like every day, things that we can actually do that have a tangible, measurable impact from this. So that's the good news, is that to me, it's that we can do something. Let's see, I just wanted to check out some of these questions. If you have any more questions, please enter them in the chat. Let's see, has anyone documented loss of native flora due to climate change yet? I don't know if you mean in North Carolina specifically, or just anywhere on the globe. I know that there have been studies of that. I guess that's not something that I've done, so I can't say, but I do know that there's been a lot of, especially in the mountains, one of the things that we're concerned about is that these highest elevation sites are really unique to the North Carolina, the sort of far southern peaks of the North Carolina mountains. And so the ecosystems there are definitely at risk of being lost because temperatures are warming and our climate is changing. So I would say, I'm sure that somebody has done a study. I cannot think of one off the top of my head. Yes, yeah, I'll make a note, and if I can find something, I'll try to pass it along. Let's see, Lucy asked a question, is Orrin Pilkey involved in the same group as yours? No, but I am definitely aware of the work, and I do respect it. And then, has the North Carolina legislature changed its policy about presenting information related to rising ocean waters? To my understanding, yes. I mean, the climate science report is very clear that we are seeing rising sea levels, and it is not expected to just be a linear rise in the future. Let's see, I think I might have missed one. So how much does the heat island effect of cities impact climate change? Are any cities seriously addressing their heat island effect? Yeah, so it's I guess an amplifying thing, right? If you have temperatures that are warming, and then you have the urban heat island, if they can really compound each other and create, especially during a heat wave event, really create a problem. So things that I've seen cities doing are looking at planting more trees, doing more green roofs, basically anything you can do to get green, growing things in there will help cool it. It's kind of challenging for things like New York City, right, which is just so dense and so much concrete to cool something like that. And so places like that, what I've seen are looking at where are the places that don't have air conditioning. Can we retrofit those buildings so that when there is a heat wave that people inside those buildings, right, because the heat wave persists sometimes inside the concrete buildings even after things might cool down, say at night your building might still really, really warm. So looking at ways to make the infrastructure more resilient so that people can better withstand it. David asked, any perspective on how fast plants adapt to these new climate conditions, both agriculture, commercial, and gardens and native plants? I think there's natural selection happening all the time, right? So if we have plants, if plants are experiencing warmer conditions, or they're experiencing more sort of feast or famine when it comes to rainfall, the seeds that make it to the next generation are going to be the ones that were developed through that. So I think there's that at play. I don't know. I guess I can't really speak so much to just like humans not having intervention in plants. I do know there's a lot of work happening. I feel like every time I do like a Google Scholar search for anything on plants, commercially grown plants, there's a lot of research on how do we get the best wheat variety that can withstand warmer nighttime temperatures, or berries that need to accumulate a certain number of cold hours in the winter to know when to come out of dormants. How can we get ones that maybe previously they needed this much cooling and now they just need a little bit less because we're not going to get as much cooling in the future. So there's a lot of work on breeding plants for that. And NC State actually has a new plant sciences initiative, and I think that they're doing some of that work there as well. Let's see. Ladorna mentioned rising sea levels are drowning islands in the Chesapeake Bay. Yes, and we are, I didn't talk about sea level rise here, but we are seeing it happen in eastern North Carolina, particularly in the northeastern part of the state. We're seeing a lot of those impacts, including with saltwater intrusion, land that was previously used for farming. If that water comes in and is salty, or if you have a hurricane and the storm surge makes it farther inland and leaves that salt behind, it's no longer as good of a soil to grow those corn in or trees in, right? Do I have any thoughts about the recent ongoing heat wave in the Northwest and other temperate rainforests and winter mountains? Yeah, so I have a lot of thoughts about it. Most of them are really sad. Yeah, I guess I don't really know how to respond, my thoughts on that. I will say that the heat wave that we saw in the Pacific Northwest, that there's already been some quick studies to look at to say, yeah, this could not have happened without climate change. They get heat waves there. They get, oh, sorry, I don't know if you heard that. We're getting some thunder here. Just like how I mentioned in the first part of my talk with the Bermuda high pressure over the ocean, sometimes it extends over us and we get kind of high pressure. We can get a heat wave or drought. So that sort of a similar process there. They call it sometimes the the heat dome. So it's just a big area of high pressure that sits over them. So yeah, they've seen just incredible heat, incredible records being set. There's a lot of coming out now, starting to see some of those ecological impacts to the marine life, to trees, to fish, right? So I think we certainly get heat waves here. We are a lot more humid, so I hope that will protect us some. But heat's a really real concern here, and actually one of the things that my office is doing this summer, partnering with some other groups, is to map the heat island of the Raleigh-Durham area. This is it's a national initiative to map the heat islands of different cities across the country. And I think that there's interest in doing the mountains as well, because I feel like nobody ever talks about the mountains being hot, but they get hot, right? So I'll stop there because I think I'll just keep rambling. I think that might be all of the questions. I'll stop sharing my screen. If anybody wants to unmute themselves and ask a question, please feel free to as well.
I want to thank you, Rebecca, so much for joining us tonight and giving such a great presentation. Lots of very specific information for the mountains. So if we don't have any other questions, thank you everybody for joining us. Bravo. We'll see you next week. And Rebecca, I hope you can join us too.
Yeah, I hope to join. Well, thank you all so much. And I have a great night. Please don't be too sad.
All right. Good night, everybody. Thank you.